Okay, here just now, our identity for cos 2x is this one. So this identity is to help us to change the cos square into cos, so that we can integrate the cos, because we cannot integrate the cos square. Same thing here, cos 2x equal to this identity. So the sine square x is equal to this. So the sine square is not here, so we cannot integrate sine square. But when you change using this identity, it will become cos, where you can use this one, number 2, to integrate. Okay, now you look at this identity. Actually, this sine 3x is 3 sine x minus 4 sine cube x. Actually, this is not in your syllabus, but you can remember this one. You can use this. So this identity is for you to change the cube, sine cube, the sine cube. Just now is sine square, but now is sine cube, to become sine, so that the sine and the sine we can integrate. Integrate the sine, become negative cos. Same thing here. Cos 3x, this also not in your syllabus, but you can memorize. So cos 3x is 4 cos cube x minus 3 cos x. So the cos cube you change, that means the cos cube you cannot integrate, not here. But when you use this identity, the cos cube will become cos and cos. Therefore, you can use number 2 to integrate to give you sine. Okay, I give you an example. You see. Okay, let's say, look at this. I'm going to integrate sine cube. Okay, sine cube. So you can't integrate sine cube because here we have only sine and cos. So I use this identity. Sine cube is 3 sine x minus sine 3x over 4. So I just substitute the identity here. Then I separate them. 3 upon 4 sine x. Then this is minus 1 over 4 sine 3x. So now the sine I'm going to integrate to give me negative cos. This one will give me negative cos. This one also will give me negative cos. But here you see I need to have a 1 here, isn't it? Because differentiate x I have 1. I get 1. So this is 1. So this is 1 over 1. There means no change. But here when I differentiate this, I get 3. Then this one I should have 1 over 3. That's why I get 1 over 12. And then I integrate sine negative cos, so I get this. So this will be the answer. Okay? So actually for sine cube x, besides using this identity, actually there is another way. That's why I say if you can memorize the identity, of course you can use. If you cannot, you use the other way. Now I show you how to use. Okay, sine cube x actually can be written as sine x, sine square x, because it is cube. And then the sine square you can change using 1 minus cos square x identity. Then I multiply inside. I will get, this is sine x, where the sine I'm going to integrate. And then here when I multiply, I get sine x cos x square. So here I'm going to integrate the square, the 2, the power 2. Here I'm going to integrate the sine. So when I integrate the sine, will give me negative cos. When I integrate these 2, will give me 3 upon 3. Is it? But we have to check. When I differentiate this, I have 1. So I don't have to add anything, which is 1. But here, when I want to integrate, I have to substitute this. When I substitute, when I have to differentiate this, when I differentiate the cos x, I have negative sign. So I must have a negative and negative 1. That's why here I get plus 1. So cos 3x over 3. Is it? So this is the answer. But you notice that this answer and this answer is not the same, isn't it? But actually they are the same. I can show you. Because this one is cos x, this is cos 3x, this is cos cube x. I can change this one cos 3x back into cos 3x, you see? I use this identity again. Okay? This identity. Cos cube x is this one. So I substitute inside. So when I substitute inside, then I simplify. Okay? Then you will get back the same thing. This simplified part, you know how to do it. So you will get back the same thing. Okay? That is how we integrate cube. Okay, let's say I give you this. Cos cube 1 over 4x. So you can use the identity. Cos cube is this one. So now I change the x into 1 over 4x, 1 over 4x, 1 over 4x. Therefore I get this. Therefore I will get this, and then I take out this one, 1 over 4, then I have this, okay? I have this 1 over 4, then this one, and then this one is 3 over 4, then this one, the dx is here, okay? Therefore you see 1 over 3. Now the cos I can integrate to give me sine, and then here also the same thing. This cos will integrate to give me sine, isn't it? But here when I differentiate, I have 3 upon 4, so this is 1 over 3 upon 4, which is 4 upon 3, so it's 1/3. That's why I have 1/3 here. Here when I differentiate, I get 1 over 4, then this is 1 over 1 over 4, which is 4, so I multiply, I get 3. That's why I get this. So this will be the answer. Okay, there's another one without using, what I said just now, without using this identity, we can do it also, we separate them. For this one I simplify, I simplify sine 3x, I simplify, I will get this, okay? Use the identity, sine 3x is this one, 3 sine x minus 4 sine cube x. So I use identity, I get this. Okay, another way of solving this, I separate them. Then this one cos square can become 1 minus sine square. Then I multiply inside, I have cos for x, then this one is cos. Okay, for this part, I'm going to integrate the cos, but for this part, I'm going to integrate the 2. When I integrate the 2, I get power 3 over 3. When I integrate cos, I have sine. So because I want to integrate this here, I must have 1 over 4. I must have 1 over 4, so 1 over 4, which is 4. And then here, when I want to integrate the 2 to give me 3 upon 3, I have to differentiate this. Differentiate the sine, I have cos 1 over 4x, and differentiate 1 over 4, I get 1 over 4 here, 1 over 1 over 4, which is 4. Okay, so this is what I get. So when I simplify, I get this. You check and see, the answer is the same one. Okay, that is how we integrate. Okay, now we come to this. Let's say I want to integrate this. I want to integrate sine 3x. Okay, so I use this identity. Okay, 3 sine x, sine 3 x over 4. So 3 sine x minus sine 3x over 4. So I'm using the identity. Therefore, here 3 upon 4, I take out sine, which I'm going to integrate afterwards. And then minus 1 over 4 sine, this one I multiply in the 3, I get 3x minus pi, then dx. Okay, so here, if I'm going to integrate here, sine will give me negative cos. Okay, but here I must have a 1. So if 1, no change, still the same, sine become negative cos. How about this part? Sine will give me negative cos. But here, because of 3x, when I differentiate the 3x, I must have a 3. So this is 1 over 3. Therefore, this is 1 over 12. Okay? Then, after that, I take out the negative. Okay? Take out the negative, become positive. Then I substitute cos, this one negative. Okay, cos of negative angle, the negative you can just ignore. That's what we learned before. First semester, for cos negative angle, the negative you can just ignore. So you get this, the negative angle, you just ignore it. Then this is square root 3 upon 2, because this is cos 30 degree, cos 60 is half, cos 90 is 0, cos 180 is negative 1. So you simplify, you will get this. This is the answer. Okay? Then another way of doing, you can do it like this as well. Same question. Like just now I said, this one you can break into sine and sine square. So the sine square you can use 1 minus cos square, which is identity. Then after that you multiply this one inside, you get this, and then this one you multiply, you get this. So here I'm going to integrate the sine, here I'm going to integrate the square. Okay, I'm going to integrate the square. So when you integrate the sine, you get negative cos. Then you differentiate this, you will get 1, so no change. But here also, when you want to integrate 3, you get 3 upon 3. Okay, you integrate square, you get 3 upon 3. And then here you differentiate, cos you have negative sign, so here you must have a negative 1 over 1 negative, that's why it becomes positive, and then you differentiate the x, you get 1. So you get this. After that you just simplify, then you substitute again, the cos of negative angle is become positive, you just ignore them, so you have all this, and then after that you simplify cos 30 degrees 30 degrees, yes, so 3 over 2, 60 is half, and then this one cube. Okay, then you simplify, you will get the same answer. Okay.